So now we are starting with next chapter. Eigenvalues and eigenvectors. So if I have any n cross n matrix like this, then we can form the matrix A minus lambda I, where I denotes n cross n unit matrix. Then the determinant of A minus lambda I equal to 0 is known as characteristic equation of A. So what will be A minus lambda I? If A is this n cross n matrix, A11, A12, so on till A1n, A21, A22, so on till A2n, AN1, AN2, ANn. So A minus lambda I equal to 0 will be A11 minus lambda, A12, so on till A1n, A21, A22 minus lambda, so on till A2n, AN1, AN2, so on till ANn minus lambda equal to 0. Now if Ax is equals to lambda x, here A is the given n cross n matrix. What does x denote? Vector. Eigenvector. Lambda is eigenvalue. X denotes eigenvector. For example, if I have a matrix of order 3 cross 3, so if I simply find the determinant, after that I will discuss tricks also. Determinant of A minus lambda I equal to 0. This will be 1 minus lambda 1 1 1 1 minus lambda 1. So on opening the determinant, I will get 1 minus lambda, 1 minus lambda square minus 1 minus 1, 1 minus lambda minus 1 plus 1, 1 minus 1 plus lambda equal to 0. 1 minus lambda, 1 minus lambda square minus 1. This 1 will get cancelled out. This will get cancelled out. This will be plus lambda. Plus lambda means 2 lambda. 1 minus lambda cube minus 1 plus lambda plus 2 lambda equal to 0. So 1 minus lambda cube minus 3 lambda plus 3 lambda square minus 3 lambda minus 1 plus 3 lambda equal to 0. 3 lambda will get cancelled out. This will get cancelled out. And I can take lambda square common, minus lambda common. Lambda minus 3 equal to 0. So from here, eigenvalues are 0, 0, 3. Now some important results. So if I want to find the characteristic polynomial of A, and matrix order is 2 cross 2. Then A minus lambda equal to 0. Simply you can remember that lambda square minus trace of matrix A lambda plus determinant of A means alternate plus minus sign. Plus sign, then minus sign, then plus sign equal to 0. Then this will be characteristic polynomial of A. Your time will be saved na of solving this long determinant, 3 cross 3 determinant. And for 3 cross 3 also, lambda cube minus trace of matrix A lambda square plus trace of adjoint of A minus determinant of A is characteristic polynomial of A. For example, 1, 2, 3, 4, 5, 6, 7, 8, 9. So I need to find characteristic polynomial A cube, x cube minus trace of A. What is trace of A? Sum of diagonal entries. 1 plus 5 plus 9, 15. Now trace of adjoint A. Adjoint A. Simply I need to find diagonal entries only because trace is sum of diagonal entries. So A11 entry. 5 nines are 45 minus 48 minus 3. A22 9 minus 21 minus 12. A33 5 minus 8 minus 3. So trace will be sum of diagonal entries, trace of adjoint A na minus 3 minus 12 minus 3 minus 18 lambda. Then determinant of A. What will be determinant of A? Just finding. Here you don't need to find. Reason is R1 plus R3 and divided by 2. You will get R2. Check this. Means scalar multiplication. Scalar multiple. है ना? 1 plus 7 8 divided by 2
it will be
4.
0. 0.
That's why determinant will be 0. So this is characteristic polynomial. X cube minus 15x square minus 18x. So I can simply take x common. X square minus 15x minus 18. One, two, two, 4. What will be characteristic polynomial for this? X square minus trace of A 5 plus determinant. Determinant is 0 na?
Yes, ma'am.
So eigenvalues will be
0 and 5.
Next trick. If matrix A is of rank 1, then one eigenvalue is trace of matrix A and remaining eigenvalues are 0. For example, the first matrix which I took was, this is a rank 1 matrix, na? Number of non-zero rows are only 1. Rank of A is 1. So eigenvalues will be, trace of A means 3 and rest will be 0. It is a 3 cross 3 order matrix, na? So there will be 3 eigenvalues. And by finding determinant of A minus lambda equal to 0 also, I got the same eigenvalues. Now tell me what will be the eigenvalues for this.
Five zero zero zero.
This is a rank 1 matrix. So trace and rest will be 0, 0, 0. Sum of roots is equals to sum of eigenvalues, which is trace of matrix A. Product of roots is equals to product of eigenvalues, which is determinant of A. Please mute yourself. If 0 is one of the eigenvalue, then matrix is singular, means its determinant will be 0. If matrix is non-singular, non-singular means determinant is non-zero, then all the eigenvalues are non-zero. Let us discuss some more examples. Now I need to find the eigenvalues by using a simple trick that if each column sum or each row sum is same, then one of the eigenvalue will be that sum only. Means here row sum will be 1 plus 2 plus 3, 6. 5 plus 2 minus 1, 6. 10 plus 3 minus 7, 6. So one of the eigenvalue is 6, na? and rest can be computed by using trace and determinant. Trace will be lambda 1 plus lambda 2 plus lambda 3 equal to sum of diagonal entries 1 plus 2 minus 7 minus 4. Lambda 2 plus lambda 3 is equals to minus 4 minus 6 minus 10, and determinant of A. Now what will be determinant of A here? Minus 14 plus 3 minus 2 minus 35 plus 10, 15 minus 20, minus 12 minus 25 minus 2 minus 2 minus plus 50 minus 5 into 3 minus 15, 50 minus 27, 23. So lambda 2 lambda 3 is 23 by 6. Now you can put lambda 3 as minus 10 minus lambda 2 and
Ma'am, determinant is coming to be 24.
24.
Minus 14 plus 3 is minus 11.
Sorry. वही मैं सोच रही थी कि 23 by 6 अजीब सा आ रहा है. 24 by 6. Now from here lambda 2 can be easily computed and lambda 3 can be computed very easily. Okay. Now in this example, tell me the eigenvalues 2, 10, 2, 4, 20, minus 10, 6, 30, minus 22.
So one value is 0, one is 14.
Row sum is 14. So one of the
So-
eigenvalue is 14.
14.
And next
And
eigenvalue,
another one is 0 and second one is also 14. 14, 14, 0 आ रहा है.
why second eigenvalue is 0?
Determinant is 0.
Okay, or you can also say that second column is scalar multiple of first column.
Yes.
Na? If you
Hmm.
multiply this by 5, you will get second column again.
Yes.
So determinant. And the rest can be computed by trace. Trace was my 0 na?
So trace is also 0.
Third eigenvalue will be minus 14 na?
Minus 14. Yes.
1 2 3 1 3 7 0 0 9. Try this. This is a different concept. Here you can see that if I multiply this by 0 0 1, then I will get 0 0 9 na? 0 0 9 means 9 times of 0 0 1. This is ax equal to lambda x. So whenever I have like this is a multiple of e3 na?
Hmm.
E3 is 0 0 1 na? So one of the eigenvalue will be 9 and rest can be computed by using trace and determinant. Okay. Similarly, if I have another example, try this.
That means in this case, one eigenvalue is 6 and another is 10.
Hmm.
And the determinant is 0. So one eigenvalue is 0.
Hmm.
So now we rest
Or
with
you can
7,
also say
16,
that
26.
row
So
1.
third one is 10.
Hmm.
Fourth one is 10.
Hmm. Row 1 is a scalar multiple of, I mean third row is a scalar multiple of first row. If I multiply first row, sorry, first row, nee, first column. If I multiply this by 3, I will get third column. Row wise also, if I multiply this first row by 3, I will get third row. The eigenvalue of the matrix A equal to 2 0 0 1 4 0 1 3 1 5 2 0 0 1 are option A 3 2 3 4, option B 4 5 1 0, option C 0 3 4 5, and option D 1 2 4 5. Now here you can use the concept of block matrix. block matrix can be written like this: A 0 0 B, like this, or A C 0 B, or A C 0 B. Now here I can form the block like this, you know, this type. Now I can find the eigenvalues for this. This is a 1 cross 1 matrix, na? No? This is a 1 cross 1 matrix, so one of the eigenvalue will be 1. What will be the eigenvalues for this matrix? Eigenvalues will lie on the diagonal entries because it is a upper triangular matrix.
Yes, 2, 4, 5.
So option D. अगर बिना ट्रिक्स के करें तो फिर 4 क्रॉस 4 का डिटर्मिनेंट ओपन करना ही बहुत टाइम कंज्यूमिंग है, और यहाँ और कोई ट्रिक भी नहीं लग रही थी, रो सम, कॉलम सम या फिर रैंक वगैरह कुछ भी। सो यहाँ पे ब्लॉक मैट्रिक्स यूजफुल है जब हमारा बड़ा मैट्रिक्स दिया हो, मतलब 3 ऑर्डर से बड़ा दिया हो तो। जैसे ये वाला हो अगर, सिक्स क्रॉस सिक्स का। Try this. Firstly, tell me what will be the blocks.
अगर इसको 3 क्रॉस 3 के ब्लॉक्स में कन्वर्ट करते हैं तो फर्स्ट वाला जैसे हो जाएगा 1 1 1, तो ये आपका
3 क्रॉस 3 से बेटर ये नहीं है कि इस तरीके से करूँ, क्योंकि ये वाला पूरा का पूरा मेरा रैंक 1 बन रहा है। ये बेटर नहीं है। So this part is rank 1. So eigenvalue will be trace 1 plus 2 3 plus 3 6 plus 4 10, and rest will be 0 0. And what will be eigenvalues for this matrix? Row sum is 6 na, so one of the eigenvalue will be 6, and another value can be computed by using trace. Trace is 0, so minus 6. 6 minus 6. Is this clear?
Yes, ma'am.
Okay. Now next concept is algebraic multiplicity. So algebraic multiplicity simply means multiplicity of lambda. For example, if I have a matrix, I have already computed that eigenvalues are, this is rank 1 matrix, 3 0 0. Now eigenvalues are 0 and 3, algebraic multiplicity. How many times 0 eigenvalue is there? 2 times, so its AM is 2. 3 is a thing, 1 time only, so its AM is 1. Okay. Now if I find eigenvector corresponding to lambda equal to 0, a minus lambda 1 I x equal to 0. Lambda 1 is 0, so ax equal to 0. So all the equations will be x plus y plus z equal to 0. So x will be minus y minus z. Eigenvector will be like this, and x was minus y minus z. I can take y common, minus 1 1 0 plus z, minus 1 0 1. This means that there are infinitely many eigenvectors corresponding to lambda equal to 0, because y and z are free variables, na? This means that number of linearly independent eigenvectors are 2, na? There are 2 eigenvectors. Linearly independent eigenvectors है ना ये, corresponding to lambda equal to 0. And number of linearly eigenvectors corresponding to a particular value of lambda is known as geometric multiplicity. So GM of 0 will be number of Li eigenvectors, which is 2. And if you will check corresponding to lambda equal to 3, then GM will be 1. We want to find lambda equal to 3. So A minus lambda 2I equal to 0. So if you add these two equations, you will get 2x minus y minus z equal to 0. And add this first equation, minus 2x plus y plus z equal to 0. तो सेम ही हो गया ना माइनस कॉमन लेके. मतलब ये था कि एक आइगन वेक्टर की वैल्यू निकालनी थी. माइनस 2x प्लस वाई प्लस जेड, एक्स माइनस 2y प्लस जेड इक्वल टू 0.
दोनों को सब्ट्रैक्ट करते हैं तो
सेकंड और थर्ड को?
हम थर्ड को सेकंड एंड थर्ड को सब्ट्रैक्ट कर सकते हैं, तो
हम्म
y ऑफ z में रिलेशनशिप आ जाएगी।
हम्म ट्रैक कर दूंगी तो माइनस 3y plus 3z equal to 0, so y equal to z, so x will be 2y minus z, 2z minus z, so z only. So eigenvector will be z, z and z. So if I take z common, then it will be 1 1 1. So I will get only one linearly independent eigenvector. So that's why GM is 1. So whenever AM is 1, then you can directly write GM as 1. No need to find this eigenvector. Okay. So one small note that geometric multiplicity of lambda is always greater than equal to 1, and GM of lambda is always less than equal to AM of lambda. Means GM of lambda can never be greater than AM of lambda. Now we will learn another formula for GM of lambda. We know that AX is equals to lambda x. This means that A minus lambda I x is equals to 0. So from here x belongs to kernel of A minus lambda I. Na? So GM of lambda is, and number of linearly independent eigenvectors are these vectors only, na? These eigenvectors only. And what is kernel of A minus lambda I? Nullity. Now I can apply rank nullity theorem. N minus rank of A minus lambda I. So formula of GM of lambda is clear. How it is derived.
Yes, ma'am.
Okay. Matrix A is so firstly find eigenvalues, then AM and GM. यहाँ पे प्लस 0 को
0 minus 2 and 6.
Rank 1 matrix.
Oh,
Rank 1 matrix, na? So eigenvalue will be trace and rest will be 0. So eigenvalues are 0 and 6. Now I need to find AM and GM. For lambda equal to 0, AM will be 3, GM will be 1. Now find GM for lambda equal to 0. Formula is 4 minus rank of A minus lambda I. Lambda is 0. 4 minus rank of A. And rank of A is 1. GM is 3. So firstly, what will be the eigenvalues?
it is 5577.
Means 2 times 5 and 2 times 7. What will be GM?
Two. That means AM is 2 and GM is 2. For 5 it is 2. And for 7 it is also 2.
GM of lambda equal to 5 is 4 minus rank of A minus 5i. So if I subtract 5 from these diagonal entries, then first 2 row will be 0. Number of non-zero rows will be 2. 4 minus rank of A minus 7i. Minus 2 0 0 0 minus 2 0 0 0 0 0 and 0 0. There are 3 non-zero rows, na?
Yes, 3.
So GM will be 1. Find the eigenvalues also and AMGM.
eigenvalues are 5 and then 0, 0, 0.
One of the eigenvalue will be 5. And first row is scalar multiple of third row. That's why determinant is 0. So one of the eigenvalue is 0. And rest you can see this column sum is also 5 na? Every column sum is 5 and rest can be computed by using trace. Lambda 1 plus lambda 2 plus lambda 3 plus lambda 4 is equals to trace, and trace is 1 plus 5 6, 6 plus 6 12, minus 7 5. Lambda 4 will be 5 minus 10 minus 5. Yes, correct. Eigenvalues are 0, minus 5 and 5. AM is 1, 1 and 2. So GM will be 1, 1. And what about this? GM of lambda equal to 5 is?
It says 5 and then 3 zeros.
In this question?
Yes.
Reason?
Reason being the trace is 5, one eigenvalue is 5, and determinant is 0. So if I get that lambda 1 plus lambda 2 plus lambda 3 plus lambda 4 equal to 5, then 5 plus 0, then lambda 3 plus lambda 4 will be 5, and determinant is the product of the eigenvalues. So since 1 is 0, so lambda 3 into lambda 4 will be 0. So lambda 3 into lambda 4 will be 0 only when one of them is 0.
I have done the simple concept only. This is a multiple of E2.
Yes.
So one of the eigenvalue will be 5.
Okay.
And row 1 is scalar multiple of row 3. That's why determinant is 0. So
Yes, and
definitely
column first and third column is also one of the multiple of other columns.
first or third?
Third column.
First or
नहीं
third?
sorry नहीं first and third नहीं आ रहा sorry नहीं आ रहा 4 है वहाँ पे.
So determinant is 0. That's why one of the eigenvalue is 0.
अच्छा ठीक है क्लियर हो गया मुझे वो प्रोडक्ट से तो वैसे 0 से 0 आएगा ठीक है.
फिर कॉलम
So
सम
number
5.
3 1 is 5 and another is minus 5.
अब हम कर रहे थे
GM
GM of
0. So AM और 5 के corresponding देते हैं.
तो डायगोनल एंट्री से 5 हटा देते हैं. -4 0 2 2 2 3 4 0 4 -6 3 0 1 -4 4 0 8 -7 -5 -12. So what will be rank?
3.
Lambda equal to 5 corresponding rank will be
3 आ रही है.
3 थोड़ा सा इसको करते हैं R2 और
4 plus 4
पहले ऐसा कर देते हैं इसको 2 से डिवाइड ही कर देते हैं R4 को. -4 2 3 4 0 0 0 2 4 1 8 1 -3 -2 -6. इसके नीचे वाली एंट्री 0 बनाते हैं एक बार। फोर टाइम्स ऑफ R4 प्लस R1। 2 3 4 0 0 0 4 times of R4 plus R1. Sorry, 2 times of R3. 8 plus 2 10. 5 20. 4 times of R4 means minus 12 plus 2 minus 10. Minus 8 plus 3 minus 5. Minus 24 plus 4 minus 20. 2 आ गया ना। So there are 2 non-zero rows, so rank is 2. Is this clear?
Yes, sir.
Okay. Firstly, I am writing the statement of Cayley-Hamilton theorem. Every matrix satisfies its own characteristic equation that is, if the characteristic equation for the nth order square matrix A is minus 1 to the power n lambda to the power n plus k1 lambda to the power n minus 1, so on till kn equal to 0, then minus 1 to the power n a simply every matrix satisfies its own characteristic equation. For example, verify Cayley-Hamilton theorem for the matrix A equal to 1 2 4 3 and find its inverse. Also express 4a cube minus 3a square minus 12a minus 15i as a linear polynomial in A. So let us firstly find the characteristic equation. It is given by x square minus trace
4 lambda. Yes, 4
plus
x
determinant
minus 5.
Now I need to find, I need to verify Cayley-Hamilton theorem, means a square minus 4a minus 5y should be 0. I need to verify this. So a square 1 2 4 3, this will be 1 plus 8 9, 4 plus 12 16, 2 plus 6 8, 8 plus 9 17. A square minus 4a minus 5i minus 5 1 0 0 1. 9 minus 4 5 minus 5 0. 16 minus 16 0. 8 minus 8 0. 17 minus 12 5 minus 5 0. Clearly it is satisfied now. A satisfies its characteristic equation. Now I need to write this as a linear polynomial. So I will use this characteristic equation only. A square minus 4a minus 5i. A square minus 4a is equals to 5i. I am writing like this. Now I need to find A inverse. 4a is equals to a square minus 5i. Or I can simply take a common now. So a inverse 1 upon 5 a minus 4i. Now further I have 4a cube minus 3a square minus 12a minus 5i. 4a square minus 3a square minus 12a minus 5i. I can replace a square as 4a plus 5i now. So this will be 16a square plus 20a minus 12a minus 15i minus 12a minus 5i. Again I can replace a square as 4a plus 5i. 20 plus 20 minus 12 8 minus 12 minus 4a. This will be minus 28i. 64a plus 80i minus 4a minus 20i. 60a plus 60i, which is clearly linear in A. Next example. I have a matrix like this 1 0 0 3. Clearly matrix A has integer entries. So what will be the characteristic polynomial? X
It
square,
is x square minus 4
sorry, minus 4x
plus 3.
Hmm. So it can be written as, or I can use it simply. And by Cayley-Hamilton theorem, a square minus 4a plus 3i equal to 0. So if I find a inverse from this, a inverse will be minus 1 by 3 a minus 4i, or I want to adjust this minus sign, minus a plus 4i. Now you can clearly see that matrix has integer entries, but a inverse has rational coefficients. So a small note for this, that if determinant of a is either minus 1 or 1, then a inverse has integer coefficients provided entries of matrix A are integers. If matrix A has integer entries and determinant is either 1 or minus 1, then A inverse will have integer coefficients. Next concept is of minimal polynomial of A. So it is the least degree monic polynomial satisfied by a matrix A. That is, if MA denotes the minimal polynomial corresponding to matrix A, then it will satisfy the given matrix. And also, minimal polynomial divides its characteristic polynomial. Minimal polynomial contains at least one factor of eigenvalue. For example, if I have this matrix 1 0 0 0 1 0, simple identity matrix. So firstly I will write the characteristic polynomial for this. What will be the characteristic polynomial? Tell me.
A minus 1 to cube equal to 0. Whole cube.
And I have told you that minimal polynomial divides characteristic polynomial. So what are the possibilities for minimal polynomial from this?
It could be x minus 1 whole square, or x minus 1 cube.
But I have told you that it should be least degree. No?
So x minus 1.
Yes. Next example. Now for this matrix, what will be the eigenvalues?
4, 0, 0, 0.
Rank 1 matrix. Characteristic polynomial will be x minus 4 into x cube. So what are the possibilities for minimal polynomial? Because minimal polynomial divides characteristic polynomial.
It could be either x minus 4
Into
alone,
x.
or x minus 4 into x, or only x.
This one, no? Because I have told you that minimal polynomial contains at least one factor of eigenvalue.
It is one factor of eigenvalue. So x minus 4 into x, okay.
Eigenvalues are lambda equal to 4 and 0. AM is 1 and 3. GM is 1. So for lambda equal to 0, AM is 3. 1 second. Now I need to find minimal polynomial. For this, I can do one thing, that firstly, what will be GM? GM for lambda equal to 0.
3.
GM for lambda equal to 0 is also 3. Then take this GM and I will do partition of this 3. What are the possible partitions?
It is 1 plus 1 plus 1. Then 1 plus 2.
I will take that partition in which there are partitions equal to AM. AM is 3 now. So I will take this partition.
Number of partitions should be equal to AM. Right?
Number of partitions should be equal to AM. So, and I will take the highest part of that partition. Highest part is obviously 1 only. So it will be x and into x minus 4, because GM is 1 only na. So I will have only one factor in this x minus 4. X minus 4 square is obviously not possible. X minus 4 was not an issue. I need to decide the power of x. So it can be decided by taking the GM, and then I will do the partition of this GM, and the number of partitions should be equal to AM of that lambda. Another example. One, 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 two, 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 three, 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 minus 6, minus 6, minus 6, minus 6. Now firstly tell me the eigenvalues.
It is 0, 0, 0. All are 0.
All will be 0 because trace is also 0 and it is rank 1 matrix. So lambda is 0, AM is 4. What about GM? 3, na?
Yes, 3.
Now I will do partitions of 3. 3 partition. One second. Lambda is 4. So partition of this GM. Okay. Got the mistake. So एक्चुअली यहाँ पर भी 3 था और यहाँ पे भी 3 था, तो मैंने गलती से कह दिया कि GM का पार्टीशन करना है. नहीं, पार्टीशन हम AM का करेंगे. क्योंकि मैं मेंशन कर देती हूँ. AM का पार्टीशन करेंगे और उतनी बार करेंगे, वो वाला उठाएंगे जितनी बार GM गिवन है. Here GM was 3 and highest factor was 1. We will do the partition of AM and number of partitions is equals to GM. Now here I will do partition of AM. AM is 4. So partitions of AM. 1
It
plus
is
1,
1, 1,
2.
1, 1, 2. Yes.
And highest factor is 2.
2.
So minimal polynomial is x square. And characteristic polynomial was x to the power 4, na? Because minimal polynomial divides characteristic polynomial. Try this.
Minimum polynomial is x minus 9 का whole square into x minus 8.
I can write it as a block matrix. So eigenvalues are 8,
9, 9, 8, 8.
GM of lambda equal to 2 is, lambda equal to 8 is
2.
4 minus rank of A minus 8. Similarly, GM of lambda equal to 9 will also be
1.
Now, characteristic polynomial is so in minimal polynomial x minus 9, I need to partition this 2. How many times?
2
GM
times.
2 times. So 1 plus 1. And highest factor is 1. So x minus 8. I need to partition this. And GM is 1. So only one partition will be there. And highest factor is 2 only. So x minus 9 square. 1035276 minus 6, 309 minus 3, 5015 minus 11,
Eigenvalues are 9, 0, 1 and -4.
One of the eigenvalue will be 7,
Yes.
multiple of E2.
Yes, yes. 7 plus so another is -10.
And one of the eigenvalue will be 9 also, column sum.
0. Next is 0. So next -10 remains.
-10. Now here all the eigenvalues are distinct now. AM is 1 only na. So GM is also 1. So characteristic polynomial is x minus 7, x minus 9, x and x plus 10. So minimal polynomial is also same na. Is this clear?
Yes, ma'am.
Okay, next. Try this.
All eigenvalues are 1.
Reason?
Lower diagonal entries are zeros. So main diagonal पे 1 है.
AM is 4. What about GM?
It's 2.
So partition 3 plus 1 or 2 plus 2. If I take this, then highest factor is 3, means x minus 1 cube. If I take this, then highest factor is 2, so x minus 1 square. But I told you that in the minimal polynomial, it is least degree na. So I will choose x minus 1 square. Characteristic polynomial was x minus 1 to the power 4. Minimal polynomial will be x minus 1 cube. Is this clear? Sorry, x minus 1 square.
Yes, ma'am.
Now next concept is diagonalizability of a matrix. Let A be n cross n matrix. A is diagonalizable if A is similar two diagonal matrix, there exists P, a non-singular matrix such that P inverse AP is equals to diagonal matrix. Basically, I need a similar matrix. What was the definition of similar matrix? If I have two n cross n matrix A and B, then they are similar if there exists a non-singular matrix P such that P inverse AP is equals to B. Okay. As matrix P is non-singular, means determinant is non-zero, na? Then only P inverse of matrix P will exist. And whenever I am saying that A is similar to a diagonal matrix, then all the eigenvalues will lie on the diagonal of the matrix and rest entries will be 0, 0. These are eigenvalues of A. A is diagonalizable if and only if AM is equals to GM for each eigenvalue of A. Example, firstly tell me what will be the eigenvalues.
It's 5 and 0, 0, 0.
Rank 1 matrix. So lambda is 5 and 0, AM is 1 and 3. What will be the GM of lambda equal to 0? 4 minus rank of A. So clearly AM is equals to GM for each eigenvalue of A. So A is diagonalizable. Therefore, by definition of diagonalizable, A is similar to a diagonal matrix and that diagonal matrix has eigenvalues on its diagonal, means 5, 0, 0, 0 and rest entries are 0. So its properties will be same, na? Which properties? It is rank 1 matrix, determinant is 0. Eigenvalues will also be same. Its eigenvalues were 5, 0, 0, 0. Trace was 5. Rank was 1. Its determinant is 0. Product of all eigenvalues.
0.
Trace is 5. Rank is 1. Eigenvalues are 5, 0, 0. These four properties are same for two similar matrices. Next example. Try this question and tell me whether it is diagonalizable or not.
Diagonalizable.
What are the eigenvalues?
0, 0, 0.
AM is 0. Sorry, AM is 3. What is GM?
It is again 3 because it's a rank 0.
3 minus rank of A. Rank is 1 na?
अच्छा sorry हाँ ठीक है rank is 1 so it will be not be double rank it will be 2 GM.
रैंक 0 मैट्रिक्स तो तभी रैंक 0 तो तभी हो सकता है जब मैट्रिक्स ही 0 मैट्रिक्स हो.
इससे 0 बन जाएगी.
तो AM is not equal to GM. What about this?
It is diagonalizable.
Eigenvalues are 1 and 2. GM of lambda equal to 1 is 3 minus rank of A minus 5. Diagonalizable.
इसको डायरेक्टली भी तो बोल सकते हैं क्योंकि डायगोनल मैट्रिक्स है बोल सकते हैं डायरेक्टली कि डायगोनल मैट्रिक्स है तो डायगोनलाइजेबल हो.
नेक्स्ट मैं यही लिखवाने वाली थी अभी. Every diagonal matrix is diagonalizable but converse is not true. For example, if I take this matrix only, this is diagonalizable but given matrix was not diagonal matrix na? This is not diagonal matrix because what is a diagonal matrix? Entries are there on the diagonal only na? Rest are 0. Try this.
So it is eigenvalues are 0, -4 and 5.
Column sum is 5 and row 1 is a scalar row 2 is a scalar multiple of row 1. So determinant is 0. So one of the eigenvalue is 0 and rest can be computed by using trace. So clearly AM is also 1 and GM is also 1 na? So diagonalizable. Now try this question. Matrix A is 1 0 0, A 2 0, B C 1. A, B, C belongs to real numbers. Then M is diagonalizable. If and only if A part A is equals to BC, B part B is equals to AC, C part C is equals to AB, D part A is equals to B equal to C.
It's B.
Reason?
Or it can be C also.
It was MCQ.
Just
You can do by options, no?
yes. So it can be either B or C. One thing is clear. So
You have taken any values of A, B, C?
no, I'm not taken value. I'm just going by GM method. So and rank it becomes A minus lambda. It becomes 0 AB, 0 1 C, 0 0 0. So it will be rank 1 when A is 1 and B is C. So if A is 1, then B equal to C in B part. So if I put
So
B
to
equal
find
to
the
C, then A
one
will
second.
be 1
So
C.
to find the GM, which eigenvalues are you are taking?
I'm taking 1 to 1
1 to
because it
1.
is upper diagonal matrix. No?
GM of lambda equal to 1. And I want that it should be diagonalizable. So option D is simple. If I take all the values same, A, B, C. If I take all of them as 1, 3 minus rank of, so 3 minus 1, 2. ये तो satisfy कर गया. A equal to E equal to C. And ऐसे ही कर रहे थे आप?
Yes, ma'am. So according to me, AB and 1 C should be different. No? So so AB and 1 C should be, so A is 1, so B should be equal to C. When B is equal to C, then then it will be rank 2, sorry, GM2.
And here if I take all the values as 3, Now rank will not be 1 ना, है ना, क्योंकि ऑप्शन लेके तो डिस्कार्ड कर सकते हैं ना, मतलब कोई अगर एग्जांपल लेके तो अगर ABC 3 लिया देन रैंक इज 2 ना, so it is not diagnosable, so option D is discarded. Now next is, if I take option A is equals to B into C. If I take A as 4, B and C as 2, then what will be the scenario? 3 minus rank of 0 0 0 4 1 0 2 2 0. Again here also rank will be 2 na, rank will be 2 1. रैंक 2 आएगा ना यहाँ पे, 3 minus 2 फिर 1 आ गया, ऑप्शन ए भी रॉन्ग हुआ। अब बच गया हमारा एक सी भी और चेक करते हैं। सी इज इक्वल्स टू ए बी, सी इज इक्वल्स टू ए बी। इफ आई टेक सी एज 4, ए एंड बी एज 2, ए बी सी,
A equal to BC can be correct.
कैसे?
If I take lambda as 2, then its GM should be 1 because AM is 1. If I do that method. So in that case, A minus lambda, I become minus 1 AB, 0 0 C, 0 0 minus 1. So I need rank of A minus lambda as 2. So C should be minus 1.
बट एक पर्टिकुलर एग्जांपल के लिए आप करेक्ट कर दोगे, लेकिन एक पर्टिकुलर के लिए करेक्ट होने से हम ऑप्शन को टिक नहीं कर सकते ना, डिस्कार्ड कर पाते हैं एग्जांपल लेके तो।
Okay.
मतलब अगर आप उस वैल्यू के लिए कह रहे हो फिर कोई और वैल्यू के लिए भी वो सही आना चाहिए, सिर्फ एक वैल्यू के लिए नहीं कह सकते ना।
इक्वल टू बी सी करती हूँ तो -1 -1 +1 सी, फिर बी इक्वल टू AC के लिए भी check।
इसमें तो ऐसे कर सकते हैं कि A C D ये तीनों मैं डिस्कार्ड कर पा रही हूँ, सो ऑप्शन बी इज करेक्ट। हियर ऑल्सो रैंक इज 2 ना, so all the options are discarded, so answer is option B, B equal to AC. Which of the following matrices is not diagnosable? Option A 1 1 1 2, and option D MCQ.
D.
Reason?
Here AM is not equal to GM.
Eigenvalues are 1 and AM is GM. So lambda equal to 1 is 2 minus rank of A minus I. AM is not equal to 1. AM is not equal to GM, so not diagonalizable. And in A part, एक बार सारे देख लेते हैं. A part में क्या हुआ था? Eigenvalues were first
one is 0 and another is
0.
No, sorry. Not
Characteristic polynomial is x square minus trace plus determinant. So eigenvalues will be
distinct होंगी इसमें ना.
distinct
तो
eigenvalues.
diagnosable है.
और वो होंगी हमारी 3 plus minus root 5 by 2. That's why AM is equals to GM. So diagonalizable. And in option B,
it is also distinct 1 and 2.
Option C, what are the eigenvalues? Lambda square minus trace plus determinant plus minus iota. Again distinct eigenvalues. So option C is also discarded because it is diagonalizable. So answer is option D. Now next we will continue in tomorrow's class. Okay.